In R3, let W1 be the xy plane and W2 be the y-axis. And we need to find the basis and dimension of W1 plus W2, right? For that, first we need to get the generators for W1 and then we need to get the generators for W2, right? So here W1 is xy plane and W2 is y-axis. This is given to us. And first, let's find the generators for W1. What kind of the elements present in W1? It is your xy plane. It is given that W1 be the xy plane. So the element is x, y, 0. In xy plane, z-axis is 0, where x and y belongs to the set of real numbers. Let's take one element from W1. So let x, y, 0 belongs to W1. Then this element can be written as x, 0, 0 plus 0, y, 0. When we add this, we get this element back. So this further can be written as x into 1, 0, 0 plus y into 0, 1, 0. Right? That means what we are getting? We are getting this element to be the linear combination of this vector and this vector. So therefore, xy0 is a linear combination of 1, 0, 0 and 0, 1, 0. These two vectors, right? Okay, but xy0 was arbitrary. We can take any element from W1, right? And that element can be written as a linear combinations of these two vectors. Fine. That means every element of W1 subspace is a linear combinations of these two vectors. And when every element of W1 is a linear combinations of these vectors, we say that these two vectors generate W1. These are the generators for the subspace W1. So writing this, but xy0 was arbitrary. Therefore, every element of W1 is a linear combination of 1, 0, 0 and 0, 1, 0, right? So thus, W1 is having the generators 1, 0, 0 and 0, 1, 0. These are the generators for W1. Or we can write that W1 is generated by these two vectors. Fine. Likewise, we are now to get. Similarly, we need to get the generators for W2 also. What kind of the elements are present in W2? It is your y-axis. And for y-axis, x is 0 and z is 0. Where y is belonging to the set of real numbers. Let's take one element from W2. So let 0, y, 0 belongs to W2. Then this element can be written as y into 0, 1, 0. Right? That means this element is a linear combination of 0, 1, 0 vector. So therefore, the element belonging to W2 is a linear combination of 0, 1, 0. But this element was arbitrary. So therefore, every element of W2 is a linear combination of 0, 1, 0. And when every element of W2 is a linear combination of this vector, that means this vector generates W2. So that is 0, 1, 0 is a generator for W2 subspace. Now to get the basis and dimension of the sum of the subspaces, and W1 is generated by, yes, 1, 0, 0 and 0, 1, 0, right? W2 is generated by 0, 1, 0, only one vector. So therefore, the sum of the subspaces is generated by all these three vectors. Let's write these vectors in a matrix form. So let A be the matrix and writing these vectors in a matrix form. Alright, for the first row, I'm having the leading entry to be as 1. And because all other entries are 0 below this, so 1 becomes the leading element for the first row. For the second row, I'm having the leading entry to be as 1. But to be the leading element, this element must be 0. But to make this a leading element, this element should be 0 first. So for this, let's multiply the second row with -1 and adding its elements to the third row. So I need to change the third row by adding its elements to the second row, but second row should be first multiplied with -1. Writing the first row as it is, writing the second row as it is, I need to change the third row. So I'm getting 0 multiplied with -1, we get 0. Adding this to 0, we get 0. 1 multiplied with -1, we get -1. Adding this to 1, we get 0. 0 multiplied with -1, we get 0. Adding this to 0, we get 0. So now this leading entry becomes the leading element now, right? All other entries are 0. So this is your echelon matrix. And now writing the basis for sum of the subspaces. I'm having the two non-zero rows over here. So the basis becomes 1, 0, 0 and 0, 1, 0. That's it, right? And the dimension of sum of the subspaces is what? How many number of elements are present in the basis? 2. So the dimension of the sum of the subspaces is 2. Alright, thank you.